So in this question there is a rectangular slab of ABCD of refractive index mu1. Either refractive index is mu1 and here it is in a water where its refractive index is mu2. This is glass slab, but it is given your mu1 is greater than mu2. So this is your denser medium, this is rarer medium. So the light is incident at a surface AB of the slab. So the maximum value of A max such that the ray comes out from the other surface CD. So here when refraction happens it will strike this. Only if total internal reflection happens here it can come out through DC. If here there is no total internal reflection happening, it will get refracted here itself. So here your angle of incidence must be your critical angle or more than critical angle. So if this is maximum, this will be equal to your critical angle. Okay, so let me take some angle. Okay, let me draw it once again. Oh, I got different shape. So here a light ray is entering here, and here this is what your A max. So here it will get refracted and will get incident here, and then here this angle and this angle, this is angle of refraction here. Here angle R1 we can put, here refraction 2. Okay, and then here it will get total internally reflected, and then here it will come out. Here the refractive index is N2, inside it is N1. Okay, so here the condition is what? Here this should get totally internally reflected. This is what the condition is. But here normal refraction is happening. Okay, so at this point if you apply your formula, what is that formula? Your sin I c, your critical angle is nothing but 1 by refractive index, correct? So this is refractive index of the denser medium if one medium is air medium, but here this is water and this is glass. So be careful with this. So here let me rewrite it once again. So here your sin IC by sin 90 degree is nothing but what? Your refractive index of 2 with respect to 1. Okay, here if the light is going from here to here, okay, sin IC here, okay, that is the R2 I wrote, is equal to refractive index of 2 with respect to refractive index of 1. Okay, here then only you will get your sin IC is nothing but your N2 by N1. Okay, this is the formula for critical angle with respect to two different medias. Okay, this we know, this is your critical angle. Okay, so if I want to find what is the critical angle, your critical angle is nothing but sine inverse of your N2 by N1. This is your critical angle. Okay, but the question is what is this angle, so that this R2 will be your critical angle. Okay, this is your R2. So first let me apply your Snell's law here. Okay, so because we want to find A max, if you apply Snell's law here, what you will get? Here sine of A max divided by sine of R1, this will be equal to what? Light is going from this medium to this medium, so N1 N2 to N1, or refractive index of 1 with respect to 2. Here sine AM divided by sine R1 will be equal to N1 by N2. This is what we are getting, correct? So here we can find what is R1. Okay, so here how these two equations are related is, the question is we have to find A max. Here I have what? Your sine inverse of N2 by N1. Okay, I have this. So let me extend this. So this equation which I have here. So here what we have? We have sine AM, which is equal to what? N1 by N2 into sine R1. So we want to find what is AM. AM is sine inverse of N1 by N2 into sine R1. So now we have to get some relation from here to here. Here I have sine R1. Okay, so here if you see, okay, this is sine inverse of N1 by N2, but the options are not in this format. Okay, so N1 by N2 we have, but here this sine inverse of something is we have sine inverse of sine inverse of sine inverse of. So we have to change this in terms of sine inverse. For that this will be very useful. Okay, how it will be useful? Here I know r1, here I know r2, so try to change this r2 in terms of r1, then we can incorporate this into this equation. That how it can be done. Here use your geometry. Here this is 90 degree, so r1 plus r2 will be equal to 90 degree. Appo r1 plus r2 will be equal to 90 degree. Appo your r2 will be equal to what? 90 minus r1. Correct. So here we want r1 only, rewrite it. r1 will be equal to 90 minus r2. Appo r1 another 90 degree minus r2 is what? Sine inverse of your n2 by n1. Okay, so directly we can substitute this here. So 90 we have in the option. No, we don't have in the option. Then we can do something. Okay, so here am is equal to sine inverse of, here I have n1 by n2 sine of what I can write, sine inverse of so sine of r1 is what? 90 degree minus sine inverse of n2 by n1. Still here we don't have any 90 degree and all. So here if you see sine of 90 minus theta, sine of 90 minus theta is what? Sine inverse of n1 by n2. Sine 90 minus theta is cos theta. About this will fall in which quadrant? First quadrant, so everything is positive. About cos of sine inverse of n2 by n1. So this is what I am getting. So any option like this? So sine inverse of n1 by n2 cos of sine inverse of n2 by n1. So your option would be A.